Hey, welcome back to the channel. Hope you're all well. Thanks for joining. Today on the bench I have Harman Kardon. Another one. Surprise, surprise. Harman Kardon hk560 DC amplifier. This is a stereo receiver. This one I purchased 2 years ago and it's been sitting in limbo here. I bought it to flip. And so now it's going to get its day on the bench and it's going to get worked over. This is a really nice example of no damage. It's dirty, it's filthy, but it's got really nice clean lines. It's nice. There's no big scarring on this. So this will clean up really nice, and hopefully it sounds nice too. So I bought it with the, look at the knob is bent or something, I don't know. And I bought it knowing it's not working. It says it's got a channel out. I don't know for sure. I don't think I've ever plugged it in, but we're going to try it. So in 1978 you could buy one of these for $400 US, and if you've been watching lately, I did the hk560 integrated amplifier, exactly the same power, and I'll tell you this secret right now, it's got all the same internals as well, same amplifier. The only thing this thing has is it's got a tuner added, right? So this is essentially a 503 dressed up with a tuner, and the same power output, like I said. The video I did before that, the hk450 receiver, again, exact same internals. The only difference was it had a smaller power transformer with lower voltage and it had lower power output. This one's 40 watts, the hk503 was 40 watts, and then the 450 I think was 30. I can't remember what I measured it at, but you guys probably know before I do. So anyways, let's try this out. Everything seems intact, like nothing's really damaged. That's the thing that I like about this one. But you know, like I said, it's filthy. You can see there's grime in behind the glass. The knobs are caked with grunge, and so it's going to be a good one to clean up. So let me take the top off and have a peek around before I plug it in, and we'll try it out. Alright, lid comes off. I don't know if I've ever looked in this before or not. The lid looks fairly clean on the underside. So it's not one of those nasty smoker units. Here we go. So it looks like we have our original silicon, which is nice. I hope both channels are intact and working so that we don't have to look at these transistors. Looks like somebody replaced these transistors and they wrapped them in aluminum. I don't know why. That's the drivers. That's the drivers for this channel. And then the drivers for the other channel. Here's the drivers for the other channel. That's not kosher. I wonder, they didn't even use the right transistors here, I bet. Maybe somebody's been monkeying around with this for sure. That's okay. Another difference is they have the stabilizer diode connected to the heatsink instead of on the other ones. I've seen it, they just attach it to the driver, and the drivers need to be heat sinked. That's not adequate heat sinking. They just wrapped it with some aluminum. It's not going to help. So everything looks good back here. Nothing's been changed. It looks, the fuses look intact. Got the original caps. Tiny little things. What are these? 4700 at 50 volts. Got the original silicon. And our biasing transistors are up in the air. I think they're supposed to be down onto the heatsink. Don't know if anybody's worked on this. It looks like they have. Well, obviously they have. They replaced those transistors. The tuner looks all original. I don't think anybody's monkeyed around with it. For some reason, this is jamming. There we go. Yeah, it's hitting the board. I'll have to do something about that. So far, so good. There's the undercarriage. And yes, I was in here before because I put the screws here. I remember now. So this is all original dust. That's fine. That's good. And what do we got here on the bottom? We've got original solder joints, factory solder joints on those driver transistors, so they haven't been changed. That's interesting, but why are they wrapped up like that? I can see cracks here on this one. Cracks on this one. This thing's full of cracks, solders. Let's get close here. Alright, I can see this one here definitely has the ring of death. There's a crack around that joint. This one looks pretty... looks almost like a solder bridge here. It's very, very close to its neighbor. Actually, I think it is a solder bridge. If somebody touched up that joint, they solder bridged it. Well, we'll address that. This one has a crack. You can't see it. Maybe you can. This one here, got the ring of death. Yeah, and these are the original driver transistor solders from the factory. I don't think they've been resoldered. In fact, I don't think anything's been touched on this. Let's look at the other channel. Here's the other channel. Yeah, there's cracks everywhere. Okay. And we have the goofy ground arrangement. Look at the goofy ground wires they got running everywhere. So we're going to redo all the grounds on this for sure. Yep. I think it's... I'm going to check that solder joint. That looks like a bridge. And I'll test it with the meter. Let's test it right now. Which one was it? This one? Yeah, it's shorted. It's bridged right there. Let's check our output devices quick. Yeah, we got a short here. You can't see. This one here, that's a collector to emitter. This one here, collector to emitter is shorted as well. So I was hoping we could escape replacing the bat wings, but where are we here? This one here should be base. That one's good. Yeah, we have a problem here. Base, collector. That's not good. Yeah. You got two dead output transistors. But I might have some that I've salvaged from another receiver. And if I do, I'll put them in. And then I don't have to do the substitution thing. Good. Okay. So we need to have a good understanding of what needs to be fixed on this. We have a shorted bridge solder joint, two dead transistors. Maybe some other ones here too. The drivers might be dead as well. Okay, whenever I work on one of these, I always disassemble all the faceplate because it's got to come apart for cleaning anyway because it's filthy. So what you do is you remove the sides, the top, the left and right sides, and then you remove the top. There's 2 screws on the top, a screw here and a screw here. And once you remove the screws, the glass comes off with the top rail. And this is, you can see how dirty it is. So it's going to put this aside so it doesn't get damaged or scratched. Then you need to remove the lower half of the face. And there's a screw here. There's a screw up in here from the inside. You can get it with your screwdriver and it attaches to the faceplate. And then there's another one on the top. And there might be one down at the bottom too. But then there's a couple of catches. You just got to press it with your finger and it will pop off. Just like that. And there's one catch down here. If you press it, it pops off. And then there's 3 nuts you need to remove from the knobs. And then this faceplate comes off. And then you're going to have your LEDs attached. Pay attention to which way the LEDs go. There's a green red wire. And you can just pull these off. What was that? A spring. See, I'm already losing springs from here, so you gotta be careful. But you just pull off the connector off the LED. And sometimes they fold the wires over, and sometimes they don't. Okay, so I'll return this spring. Okay. Then once you get it off, make sure you have all your springs in place. Every button should have a spring. Got your 2 LEDs in place, and just put this someplace safe where it doesn't get damaged. We can clean this and deal with this after. Next, you're going to want to remove this dial face because we have a very sensitive needle here that's going to get bent if we touch it. So you just remove this screw and one on the bottom. Got 1 screw in the center. Didn't see that. So remove these 3 screws, and then this rail comes off. Put that aside, we'll clean it. Now you're going to want to remove this dial. So there's 2 screws here that clamp down the top of it. So remove these 2 screws on this side. And then there's a little sheet metal clamp. Okay, and that should be free, yeah. And we do the same on the bottom, or the other side, the right side. And have your soldering iron warmed up because you're going to need to desolder the meter wires. Okay, so this should be all loose. Let's tune this to the other side of the scale. And then we can remove. It might have some adhesive. If it does, just take a knife. Just like that. They don't give you much wires here. You just have to finagle this, the brown and gray wire, and provide some slack. Now you can do one of 2 things. Just snip these off right at the terminal lug, and then you can resolder that later. Alright, so let's get this. The reason I'm doing this is because this meter is very, well, it's very vulnerable to damage. So you just want to get this. There we go. And just slide it up and out. this way. Alright. No damage to the meter. And put this aside. We've got a little scratch on it, but that's okay. Put this aside, we'll clean it. And we have to protect this somehow. So I suggest maybe using tape. So, be nice if you could remove it, but it's really not an option. It's got to be really careful of the dial needle. And then you get full access for your lamps too. So this power cord has a big chunk taken out of it. You can see that it's got green slime and exposed copper. So what I'm going to do is cut this off and garbage it and put a new one on. Not much excitement here putting a new power cord on. Just the main thing to remember is feed it through the back before you start solder anything up. So I'm putting a polarized plug on. So the white wires are neutral, black is our hot. The neutral wire is going to connect to this courtesy outlet, and along with the white wire or red wire and the bleed resistor. The bleed resistor goes to the chassis, between neutral and chassis. And then the hot wire goes directly to the power switch lead. And then double insulate everything. I'm going to insulate the lug here with the heat shrink. This splice I'm going to double insulate with heat shrink, and it should all be good. Tuck it away so that it can't flop around and get pinched, and tie it down, and you're good. Just going through the audio amplifier right now, checking out some transistors. This one's here is Q412, I believe. I desoldered this one already. But look at the one below it. It's Q414. I'll wiggle it for you. Here's, if you can see that. All of the wires are, all three of the joints are cracked. Well, two of them for sure. But those are cracked solders. And here's another one. This one is, let's see which one this one is. That's Q413. Here, I'll wiggle it and you can see for yourself. You can see that wiggling. Those broken solder joints, all three of them. Here's the one below it. It's got, is a good transistor. This one, nope. Okay, we're going to do some transistor replacement here. This, let's pull these out. These are the drivers for this stereo. So we have a 2SB 647 and a 2SD 667 with a cheesy aluminum heatsink wrapped around it. Now, Harman Kardon runs these transistors pretty hot, and if you have one that's got high hours on it, you'll see that these are baked. The epoxy turns from black to like a brown as it ages and heats up, and the resin kind of deteriorates. These are just crimped in, kind of weird. I'm not a big fan of this. The problem is they run these transistors really hot. This is the 2S. Let's see, and the compound's all dried up too. It's all crusty, and so this is a 2SD 667. Good transistors. They're rated at 900 milliwatts each. But like I said, Harman Kardon runs them hot. So I'm going to replace them with these. These are Toshiba TTA 004B, TTC 004B. These are complementary. And these are good for 1.5 watts. Pretty good specs, pretty much the same or even a little bit better than these. Higher current, obviously, higher power rating. About 100 megahertz. These are, I think these are 150 megahertz transistors. These are 100. So pretty much the same speed. But the beauty of this is I can attach a little aluminum heatsink and I keep these transistors nice and cool. And let me find something. So I can get something like this aluminum plate here. It's a heatsink. And this will work. It's actually a little too large. I might have to cut it down. But heat sinking is not the end all be all. I want to make sure it's got a heat sink on it just to keep it cool, but it doesn't have to be some great big monster heat sink that's gonna. I can get actually aluminum plate, cut it, drill it, and use it as a heat sink. It'd be better than what this is. So that's the plan. Replace these drivers with these drivers and upgrade the heat sinking and the power dissipation. Keep these transistors cool. That's my thoughts. Now for the output devices, the bat wings. I don't have a spare set, complementary pair. I thought I did, but I don't. These two are good. I would run with these if I could, but I can't. So I'm going to remove those transistors, and I'm going to go with, I've tried this before and it works. These are, what are these? MJE 15028s, 15029s. I even have them already configured for bat wings. But I'm thinking this time around I'm going to drill new holes and just mount them just like that with the TO220. So what I have to do is drill a hole somewhere here and tap it for M3 thread. I'll do that for all these 4 transistors. And then we'll go with these. I think these will work. These are 50 watt transistors. These are 80 watt transistors. Better heat sinking. I don't know if it's necessary. Well, we're going to put 50 watt transistors in and we're going to try it. If we blow it up, we blow it up. We'll do something better. But right now, this is what we're doing. Alright, update time. Lots have been going on here. Lots to talk about. Okay, so I reworked the power amplifier and I put 4 new drivers in. Okay, and I tested the remainder transistors. They're fine, so I left them alone. So everything in this amplifier should be 100%, or in the driver stage, up to the driver stage, and including the outputs. And then I installed outputs. I always do this when I install new transistors, is I go through and I check for any ground faults between the chassis and the collectors of these transistors, just to make sure that there is no shorts on. See, there's the screw and there's the collector tab. Now this one here shows a short, and I'm thinking, what is going on and why is that transistor shorted? The collector tab is shorted to ground. This one's fine and this one's fine. So out of these 4 transistors, this one shorted, the collector tab shorted to ground. And now what is going on here? So I pull the screw out of the transistor, lift the transistor off the heatsink, short's still there. Oh boy, this is getting interesting. Now another interesting thing I found is these are the original fuses I pulled out from the circuit, and I had a good look at them and they're both blown. Let me see if I can zoom in and show you what is going on with these. Let me see if I can get this so you can see on here. It's difficult to see, but you can see this one here. The wire is blown and there's like a little ball of metal on the end. And same with this one. This one, the ball of metal landed back on the wire, about a millimeter. So both these fuses opened, and it's kind of hard to tell because you see the spring inside. The spring is supposed to pull it back when the link melts and break the connection. So these two are gone. I'm thinking, oh, okay. So I popped some new fuses in. This transistor, the collector tab is removed, and I still have a short. So what is going on here? Then I get my meter out and start checking some of these diodes, and guess what? Some of them are shorted. So when the catastrophic event happened, here, let's try this one. When the catastrophic event happened, it took out some of these diodes. That one's completely gone. That one's completely gone. That one's open still good. And that one. So we took out 2 diodes out of the power supply on this side, on this this channel. This channel here, power supply seems okay. We can test it. That's just capacitor I was reading. That one's okay. And that one's good. And this one's good. So we got two shorted diodes. I'll have to replace these before I do my power up. And that's where we're at now. Ready to do a power up, but I still have blown components to replace. So I'll get on that and then we'll get this thing fired up. Okay, the offending diodes are out. One came out in two pieces and one came out in one piece. Now these are, according to the service manual, these are V03Cs. Now if you look that up on data sheet, these are 1.3 amp diodes. I don't know why they use such a light diode in an application like this. They're 200 volt, 1.3 amps. Now I'm thinking, well, that's not that good. So I'm kind of looking at replacing it with a IN5404 or 540 something. Yeah, just to give, these are 3 amp diodes. I'm going to upsize these ones I'm replacing, but I don't have any new in stock right now. I'd like to replace all 8 diodes, but yeah, I just don't have the proper stock. So I might just leave them in place and replace the defective ones and call it a day. Okay, I got a couple of 1N5404 diodes installed. I'm not going to replace the rest of them because I don't have inventory, and I made a note to myself to order some suitable diodes. Now, I find this really funny that Harman Kardon put a 6.3 amp fuse or 6.25 amp fuse to protect this circuit, which is a bridge rectifier made up of 1.3 amp diodes, caps, and I guess it's all relative, but these two fuses protect both channels. They don't have separate fuses for left or right. If they did, they could have the current, you put a 3 amp fuse in here, but that still doesn't explain their reasoning for putting such a weak, feeble diode in place for the bridges. Now, it was a good thing I caught this, because if I plugged it in, it probably would have popped those two fuses again, the 6.25 amps, which I'm running low on, and I need to order more of those too. The reason the fuse blew is not because the transistors popped. It's because the diodes failed and had a direct short. And what that does, when the diode fails and has a direct short, what it does is it allows AC to go directly onto the filter caps. And AC on the filter caps is, they're not happy with that. So that's where you're going to get all your current from, and that's where you're going to get your blown fuse. But it's all been repaired now. So let's actually let's plug this thing in and try it out and see if we can avoid some more sparking. Okay, ready for first power up? Let's turn it on. Everything looks normal. It went down and then back up again. We're sitting at about 25 watts idle. Alright, so now I'll set up the bias and DC offset, and then we'll get ready for some testing. Excellent. So the spec for the bias on these is 33 millivolts across both emitter resistors, and I keep adjusting it down. It keeps wanting to climb up, but this thing's warming up. This side was really hot, but this side, and I turned it down, but this side is what I'm reading right now, and it's pretty close to being bang on. So typically these receivers should be around the 30 watt mark, 32 watts, somewhere around there. And I'm just going to keep adjusting until we get it bang on and stable, because this keeps rising. So I'm going to keep turning it down until we get a stable 33 on both channels. Okay, just a couple notes on this. This 560, there's a little bit of difference here. There's this model here is a little different in design. it has this stabilizer here attached to the heatsink. On other models, they take this stabilizer and they attach it to one of the drivers to monitor the temperature of the driver, not the heatsink. But for whatever reason, they made a change here, moved it from the driver to the heatsink. Another change they made is they removed, it used to be a 2SC1472, I believe it was, and that was a Darlington, an NPN Darlington transistor. And it used to be thermally coupled to the heatsink, but now they made a difference. This is a 2SC945, which is the jelly bean transistor. That's not coupled, so I don't know what they're doing here as far as maybe they had some heat stability problems and they're trying to fix it in the later models. These amplifiers do run hot. Harman Kardon biases their circuits really heavy, so higher current flow equals more heat. I think they're targeting lower distortion. I think that's their plan. But you can only do that so far and get away with it so much, because if things are cooking, usually you see these circuits are all cooked. If they're getting cooked too much, you get cracked solders. Transistors lose their HFE, they lose their gain, and they fail. I've seen capacitors fail in these circuits because they're cooked. It's a lot of bad things can happen from the heat. So I think they're trying to control the heat better with how they got the stabilizer mounted. I don't know if it works or not. We'll have to see. Alright, it appears we have a problem. Not a major one, minor one actually. Our power on delay isn't working. So when you turn the amplifier on, you instantly get a signal. You also get a big transition, power on transition on your speakers too, which isn't right. I can demonstrate it here for you. Okay, top trace is the left channel. Bottom trace isn't connected to anything. I can just turn it off so it doesn't confuse you. Okay, turning it on. You see how it jumped, and then what happened? I lost the signal. What's going on there? That was weird. Something. Well, maybe it's my connections. Okay. So let me demonstrate it. So you turn the power on, you get a big power surge, the line jumped up, and then our sine wave is there instantly. It's not supposed to be there, it's supposed to be a 5-second delay, and then the audio appears. So let's go have a look at the schematic, see if we can figure out why the circuit isn't working. What is part of the circuit and why isn't it working? Alright, so I did confirm it's happening on both channels. So here's one channel, the power amplifier. Here's the other channel. Can't see the whole thing, it's not important. But what we're looking at is this transistor Q405, Q406. Okay, this transistor is responsible for turning the amplifier on and off, on the power on, and I believe power off as well. It kind of shuts down the amplifier before too many weird noises come out. But the line that controls this is this line here. It goes through a 47K resistor. Goes through a Zener diode, 13-volt Zener diode, turns this transistor either on or off, depending on the signal in this line. And this channel has the same thing, but it has an independent line as well. It has its own line. So there's two lines coming down, and one for Q405, one for 406. Now that I've confirmed that it's happening on both channels, it's not something here, it has to be something earlier on that's... So let's go look. So this is the other end of the line, D11 and D12. So this is just to keep one channel from affecting the other. They put a couple diodes here. Q1 is responsible for turning this line signal on and off, and it comes from this circuit here. This line here comes from the power transformer, and this is AC voltage coming in. And then there's D13 that halfway rectifies it to a negative voltage. Okay, and then it goes through a 1K dropping resistor, and then it goes through this arrangement, which is a capacitor. This capacitor is a 33 microfarad, so that so by the time it gets through this diode, this resistor, we're getting a DC voltage here on this line, negative DC voltage that increases with time. Now, this here is the LED power indicator, and oddly enough, this isn't working either. The light is out, and I'm pretty sure I connected it the right way around. I can check if there's a voltage on here. If there is, maybe I put the LED in backwards, but I didn't move the LED. I reconnected it according to the diagrams in the service manual. So it should be working, but it isn't. So maybe that's a clue as to what's going on here. So things that could be wrong: we could have no AC coming from the transformer. D13 could be open, but I highly doubt it, or it could be shorted. R5 could be open. C8 could be installed backwards when I did the recap. C9 might be in backwards. Q1 might be defective, or we might have an open resistor somewhere in here. So I'm going to go and try and figure this out, see what I can find. Shouldn't be too difficult to figure out. It's a very simple circuit. You've got AC coming on this side, halfway rectified, and then this little circuit here is kind of like a timing circuit that this cap takes X number of seconds to charge up, and when it does, this transistor turns on, and in turn that turns the amplifiers on. So I'll start probing and I'll get back to you on this. Alright, I did some scoping and I think I found out the problem. I'm not sure yet, but this line I tested with the scope, got AC coming in, passed the diode, I got half wave rectification of negative pulses, which is correct. And then once it gets past this 1K resistor, those negative pulses drop. They get filtered and they drop to about 1 volt. So out of this thing, I'm only getting 1 volt, which is not enough. I think it should be closer to 10 volts or 8 volts or something like that. But can't figure out why I have no voltage on this line. It's very low right here. Well, I don't know what to tell you. That's one of those situations where it kind of fixes itself. I was doing a lot of probing and measuring, and I removed Q1 and tested it out of circuit. It's fine. Removed both capacitors out of the circuit, tested them. They were fine. They're brand new caps. Put it all back together, and here it is. Turn on the power, and you got your delay, and then your signal. So I don't know what to tell you guys. It fixed itself. Maybe it did. I don't know. Alright, just putting it through its paces. I did some distortion, frequency response tests, everything. Everything's good except for one thing. Left channel, when I'm near full power, did some distortion tests at 50 watts near full power, and I was getting a high distortion on the left channel, about 3 times the normal amount, and it's just on the left channel only, and it's only when I'm pushing heavy power, like I said, 50 watts. So I can show you up on the screen what it looks like. Alright, top trace is the output of the amplifier, bottom trace is the output of the distortion meter, and this is going to be a sum of all the distortion that's coming out, and it's scaled according to the range it's in. So if I keep turning this up, you can see the distortion comes up, but then our signal's coming up. You see it gets louder and then it drops, like right here, and then it drops to almost nothing. That is where it switches ranges. So let's turn this up and do full power. So right there I'm doing about 19.2 volts on the output. Pretty darn close to 50 watts. Now I'm going to increase the power slightly, and you can see how these spikes come growing up out of nowhere. Now I'm at over 50 watts a channel, and we're getting a harsh spike on the top of the waveform. Notice that the timing of it is at the top, so that tells me that something going on with the positive rail or the NPN transistor in the output stage. If I keep going, it just gets worse and worse. Let's see here. It could be early clipping on that one transistor. That's probably what it is. It shouldn't have early clipping on one side. See, I'm at 0.6% distortion. Keep going. Here's 1% distortion. And then it switches ranges and goes up. From there, I'm at 1.1%. Gets real ugly from there. So I think I have early clipping on that. And there's the normal distortion. That's probably 0.02%, right around there, which is doing pretty good. So I'm going to investigate why that one transistor's distorting early. Might just need to change it. All right, so I have not even heard this yet. So let's stereo FM. Let's try this out. I think. Okay. Do you even have any FM here?
Solide quand mes pieds sont solides, donc
That sounds alright. Getting good stereo. It's not the strongest tuner I've seen, but
Starts with Coleman's. Open 7 days a week. Take exit.
yeah, it's pretty weak.
One of my favorite. Stunning community of East Pine, nestled in the southeast corner of Beaumont, one of Canada's.
Having a real hard time picking up stereo. Even on these stronger stations, it's having a lot of troubles. So yeah, it's going to need some alignment because the stereo is quite not very sensitive.
Nobody was able to honk and steer at the same time, and it takes 2 to 3 times longer to honk than it does to steer or brake. Studies show honking.
Okay. AM. It's working good.
Resort and Casino presents the most spectacular.
AM's working a lot better than FM is.
We have managed to.
Yeah, I'm pleased with this so far. So we're going to need to do FM alignment, I think. It's I think it's showing that it's not quite up there, but we can tune that in. All right, let's do our power test here. All wired in, got my scope connected, I got my signal source. Let's turn it on. I'll show you how the power on delay works. Turning it on now. And there it is, it's working. It's amazing. I don't understand why it didn't work before, but it does work now. Okay, so I got 1000 hertz tone going in to my 8 ohm load. Let's turn this up till we get clipping. Get clipping here quite a bit. Let's back it off. I wonder. Okay, we can do this. You can see her clipping a little better. I'm going to back it off right to that point. And we got 20.96 volts RMS on the output. Start our timer. And we'll come back in a minute. Here's our power consumption, 204 watts. Alright, we're approaching 10 minutes here and I'm getting some pretty elevated temperatures. I got over 75 degrees, well 80 degrees Celsius here, 81. Getting quite hot. Yeah, very hot. 82 on this channel here. This one here is, I can't seem to get a peak on this. There we go. 75, 80 degrees. Yeah, I'm good with that. I'm going to turn this down and we'll conclude that test. Actually, it held up pretty well, except it is pumping out a lot of heat. This is getting quite hot. Let's turn the power down and let's look at some square waves. Okay, that's about a 1 watt output on this the receiver. That's our square waves, 1000 hertz tone. Let's go bass cut and bass boost, treble cut. Still a little noisy on the right channel. Treble boost. There's our balance. What else we got here? Tone defeat. That is subsonic. And this one here is, oh, that's mono. Where's the high cut? There is no high cut. Okay, loudness. Alright, let's go down in frequency. Twitchiness in the left channel here. What's going on? 100 hertz. Tone defeat. Maybe that switch is not. Got some weird stuff going on with the tone controls. Okay, let's go down. 90, 80, 70, 60, 50, 40. 30, 20. Okay. Tone defeat. Still something going on in that tone circuit in the left channel. I press tone defeat, it erases it. So that's 20 hertz square wave. It's pretty good. Let's go down. 15. 10. 8. 7. 6. 5. 4. 3. 3 hertz. It's pretty good square wave for 3 hertz. Okay. Let's go up in frequency. 2, 3, 4, 5, 6, 7, 8 kilohertz. 9, 10. That's really good for 10 kilohertz. 11, 12, 13, 14, 15, 16. 20 kilohertz. Still doing all right. Let's go to the max. Where do we lose our square wave? Somewhere around here. You think? There? Or lower? That's 65 kilohertz right there. Pretty fast. Alright, so I just finished alignment on the tuners. AM was already dialed in pretty much perfect. I didn't have to do any adjustments other than a little bit of tweaking on the dial scale accuracy. And the FM was not quite as good, but I did dial in the discriminator, was out quite a bit. And I got that, and now we're getting stereo, and it sounds pretty good. And I think I'm finished with this one. One more thing I did do is I replaced this Q1, this transistor. This is the transistor that's responsible for the power on muting delay. And I replaced it just out of caution because I think the other transistor was flaky. You know, when I had that problem when I was turning it on and it wasn't muting. So I think that should be gone now. Here's a look at some of the parts that went into it. So we got rid of all that funky wiring grounding scheme they had. That's all wires I eliminated. 2 dead transistors in the power output. Now, I think the failure on this part was the transistors, and which in turn blew the diodes. There's 2 blown diodes here, and that in turn blew these 2 fuses. So that was the chain of events, I believe. Well, the chain of events started with a bridge solder joint on the printed circuit board. I think somebody was in there trying to solder up some bad connections, and I think they mistakenly created a solder bridge, which actually just blew up the amplifier. Small signal PNP transistor. This was the power on delay, so that got replaced. 2 fuse lamps, and then all these caps. Pretty much the caps are very tired. A lot of the Mashita caps are actually failed. And I also replaced tantalum caps as well, just as a measure. So this thing's ready to go. So it's actually after I finished this video and I was doing the video editing and and I noticed it too when I was doing it during the power test, but after I was doing the editing, I watched it again. I noticed, you probably saw it too, the left channel was really flaky on this receiver. Like, you had problems. First of all, the waveforms on the square wave didn't match, so they were way out of whack with each other, which tells me there's an imbalance between the 2 channels. Plus, it had a twitchiness where we were kind of losing a bit of gain on the one left channel, which suggests to me either one of 2 things: either a bad switch connection, or a bad transistor in the circuit. So I'm going to go back in. I'm going to see if I can figure out why it was twitchy. And then when I hit the tone defeat button, I don't know if you noticed, when I hit the tone defeat button, that all went away, which tells me it's all in that part of the circuit. We could go on the schematic and have a look at it, but if you don't believe me, but that's where it's all happening, is right there in that little bit of preamp circuit. Okay, here we're wired in for a test. I have no load on the amplifier. I'm just running it with the square wave through. I'm just trying to zero in on what's going on with the twitchiness. I'm playing with the tone defeat button. You can see it's not really any problem with that. I push it in, it flattens it out, seems to be. But I remember the top trace, which is the left channel, it was quite twitchy in amplitude. And I'm trying to recreate that. I think I might have to let it warm up for a bit. So maybe I'll just let this sit on power for a while. I'll come back and check it every so often. And it seems like it's working good now. Let me go down in frequency. Maybe that might help. Let's go down to 100 hertz. Yeah, see, we're starting to see that little bit of muck up on the. And then when I hit, yeah, see, that there is what I'm talking about. That didn't sit well with me, having that difference between the two amplifiers on the low end. But that could be the new caps I put in. Maybe they haven't settled into their position, like they haven't formed. I'm just going to let this go for a while. Playing with the switch here. Just going to let this go for a while and see if the twitchiness comes back. Alright, let's have a squint at the tone circuit of the receiver. So the tone circuit starts here with the volume and balance control. This is the balance volume. And our loudness switch here is all input signal coming in from this resistor here, flowing through to this long tail pair. This long tail pair and this transistor acts like a little mini amplifier. This is a feedback circuit. That's why they brought a long tail pair into this, so they can feed back into this circuit. And then they have an output buffer here. And then a subsonic switch on the output, which is irrelevant because it's already past where our problem is. And then it feeds out this line here to the power amplifier. This is all power amplifier here. Okay, that's where we get all our power amplification. And this is the input capacitor, C401. So our problem is somewhere in here. Well, actually, it's a lot less than that. So the symptom is when the tone controls are active, we got one channel's got poor bass response. Now, it's only happening on the bottom end of the frequency spectrum. Very low. So it tells me it's in the bass circuit, not the treble circuit. The treble circuit seems fine. When I put it up to about 1 kilohertz, I don't see the difference between the two channels at all. I only see it on the very low end of the spectrum, which tells me it's a problem in the bass circuit. And it disappears when we hit the tone defeat. So when we hit the tone defeat button, this switch here, our feedback path comes from, well, first let's identify where the signal goes. The signal goes into here, and then it comes out here and goes into this transistor. And from this transistor it comes out here, and then it goes through this capacitor, this 47 microfarad. And then it goes one of two ways. It can go through the tone network, or it can go bypass the tone network here. Let's use green for bypass. So this is all bypass tone network. And when we click that switch in, that's essentially what we're doing. We're creating a path here. And this is all resistors. So resistors don't color the sound, they just attenuate. But if we go with the tone switch on, this is where the path goes. The path goes through here to the treble, okay, and then it goes through here for the bass. And then it goes through this 2.2 microfarad capacitor back to the switch. That's all our tone circuit. And considering that it's only affected on the low frequencies, something is wrong in this area here. Now it might be a resistor out of tolerance, it could be a capacitor failing or leaking or out of tolerance. Now there's this 2.2 microfarad capacitor here is a tantalum, and I can see it on the board here, and I forgot to change it but what I did is I took this 2.2 capacitor, it's a film cap, and I bridged it, and it made no difference on the signal, which isn't surprising because it's a problem in the base circuit, not a problem in the feedback circuit. So this capacitor is working, it's doing its job. I wonder if I remove it though. It might be leaking. It might be leaky, which could in effect cause a problem here, because in the treble circuit we got capacitor blocking any DC flowing through, right? In the base circuit we don't. We have resistors, and the DC can get through. So if this capacitor is leaky, it could upset the whole balance here. So I might just take that tantalum out and replace it with this to see if that's our problem. And it could be. Do tantalums go leaky? I don't know. I know they short circuit and they blow up in spectacular ways if you put power to them. But leaky, I'm not sure. Now, that might be our problem right there, is that tantalum. So let me get it. Let me replace this cap and see if our problem goes away. Alright, pulled this out and I test the tantalum. Connect up our positive. Let's get our negative. Let's have a see if this thing is leaking. This has a potential of about 9 volts across. It has 9 volt battery on the highest setting. So if I go like this, it appears we have leakage. And if we sit and watch the needle a bit, you can see it kind of goes down with time. And it's completely open there. This cap is rated at 6.3 volts. I'm putting 9 volts across it, so I could expect it to leak. But then I'm just going to sit and watch this for a bit. I have a feeling this capacitor is bad. I'm going to pull the other one out and test it as well. See, there it's climbing a bit. It's not steady. Okay, might be onto something here. Okay, what I've done here is I replaced both those tantalum capacitors with film, both 2.2 microfarad, and you can see down here in the bottom, this is from the right channel. It measures 2.3 microfarad, 10.3 ohms ESR. Where's the other one? I'll show you the other one. It's pretty darn close. Okay, there's the second one. 2.32 microfarad, 9.9 ohms ESR. Pretty close in values. Now, you can see on the scope, top traces the left channel. I'm beginning to think this is a base pot problem. If I adjust the base pot just the slightest amount off center, I can square off the top traces, but the bottom trace goes all wonky. And yeah, I happen to think it's just a little bit of imbalance in the base pot. I'm not going to replace a base pot just for that. And then of course if you hit the tone defeat button, it all erases and it's all good. But here it is. We're doing 100 Hertz right now, square wave. Let's go down in frequency. 50 Hertz. You can see there's just slight, just barely off center with the base pot, and see how it's affecting it. So yeah, it is a base pot thing. I wonder if I work it, it's not going to make it come back any better. So I guess it is what it is. I'm just going to leave it alone. Would anybody hear the difference between the two channels at those frequencies? I completely doubt it. That is like 50 hertz right there, and we're using, let's go down in frequency even more, 30 hertz, 20. And you can see it's just, yeah, it is what it is. Well, that's it for this one. I'm going to wrap it up here. I spent enough time on this one. This one was a huge time vampire. A lot of work went into it. So I'm going to probably, well, I know what I'm going to do. I'm going to test drive this thing for about 3-4 weeks, and then I'm going to offer it for sale, get rid of it. And I have no intention of keeping it, but these receivers are pretty good if you can get your hands on one of them. They're good performers, and they're I don't know, can't say enough good things about them. I really enjoy them, but I got no room for holding on to this kind of stuff, so it's got to go. Anyways, lots more HK stuff coming up. Stay tuned. I got some good ones coming, and we'll see you on the next one. Thanks for watching. Take care.